Okay, today we are going to see to identify the higher place of the town for putting our reservoir. So we can identify in different methods. The first one is we can get the elevation system by using GIS, Google Earth, as well as global mapper. But for the case of Google Earth, you may have different type of error. For example, if you use this Google Earth, we may have 3% error during of reading elevation. If you see the height of this is around 90 33 meter. So this elevation system may increase or decrease due to the uh, digital elevation model of the system or the satellite clearance. So today we'll see how to export this information into global mapper, and from global mapper you can go to the Googlers. After that, we can from Googlers we can go to GIS. After that, we can identify elevation. So to do that, the first action is saving the layer or saving after you create layer. After you create layer, by clicking here, you can create the layer as you want. So after that, you can uh, save this by right click and save properties. And you have to save in terms of KMZ format. Previously, I've already saved, that is Hawassa town, so we can leave it. Okay, after you save this, you can go to Global Mapper to export the system into AutoCAD or Excel. For this case, I need the DXA file, that is AutoCAD. So we can call this Hawassa. We can call this Hawassa. After that, you can export this. But before you export, you have to check your system must be in the form of a UTM format, or metric system. After that, in the same way, before you export the system, you have to go to the configuration tool and see the projection that is set on the UTM format, that is UTM. Unless otherwise, you cannot get the system on the GIS by making the UTM. So once you do this, you have to go to File and export vector format into DXA file. Then say OK. Included display label attribute, and the grading system must be no grid, unless otherwise, if you make it grading system, uh, you can get a different or multiple file on AutoCAD. To solve the problem, you can make it no grid system. After that, export bound data or bounded data and say it OK, and you have to save in terms of DXA format, but I'm already saved this Hawassa, so you can like this. Okay, after this, the next action, I'm already have these Googlers, I'm already have this global mapper. Okay, so we can go to GIS or ArcMap. Go to GIS and ArcMap. I think it takes a little bit time. Okay, so once you open the GIS, just click this. And the first action of developing that or set up the GIS system is set the coordination system. So if you save your system from Google Earth into Global Mapper, from Global Mapper into AutoCAD in terms of UTM zone, you have to make this one is UTM. Unless otherwise, if you start from the geographic coordinate system, you have to use WGS 9084. So my system is adapted in terms of UTM, so I just make it UTM and say it OK. After that, my uh, interest to get from GIS is elevation information, elevation information, so accurate elevation information. From GIS, we can identify the elevation information from digital elevation model of Ethiopia. Digital elevation model of Ethiopia, we do have different type of digital elevation model, that is 90 by 90, 30 by 30, and 10 by 10. But in current condition, let's use 90 by 90. But for better information, you can get digital elevation model by go to downloading the satellite image and make digital elevation model as you want the clearance. So let's make this 90 digital elevation model. Then we already have this. This digital elevation model shows us the clear information of the elevation of the entire Ethiopia. But depending on the elevation, if you see the river formation of this system is can develop in terms of cellular data or uh, cell information, that is 90 by 90 meter cell. After that, we can call our previous export data of Hawassa town, that is DXF file of Hawassa DXF file, and let's code here. Let's code here. So if you see this, look what is happening here. Hawassa is come and overlay on the digital elevation model and come and overlay the digital elevation model. But this is almost image cannot tell us the information of the background, so we need to process this image by creating shapefile. This is all. This is map only, but to create shapefile, so we can go to arc catalog and on desktop water gems is, already have, okay, and this Hawassa digital elevation model. Let's create a layer. Let's create a layer by rename the layer uh, shapefile. This is Hawassa city Hawassa city, and we can make shapefile in terms of point, polyline, polygon, multi-point, and multi-patch. But for the case of area system, we need to consider polygon for getting area. And if you want to edit the coordination system, you have to make similar that you import from your previous data. So let's okay once you finish this and make it okay. Directly when you finish this, you can get a Hawassa city shapefile. So we don't need to this DXA file. We don't need this DXA file. But before you remove this DXA file, you have to introduce Hawassa city shapefile and the current map by go to the editor tool, start editor, and we need to edit the Hawassa city. This edit format must be done in terms of polygon. To do that, just go to this layer in front of editor toolbar. You can get this create feature. In this create feature, you may get directly Hawassa city. So click on Hawassa city and select here the polygon. After that, go to here, click here, click, 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 click. Yeah, when you click, you have to be care because not to miss the information that you collect from AutoCAD, because mm, just by zooming in and zoom out, you have to make the right system. So just make it do this. Okay, so when you finish, just make it finish sketch, and you already finished the Hawassa city shape file, and you have to go to the editor toolbar and save it. After that, just go to uh, stop stop editing. So once you stop editing, you already found the Hawassa shape file. Even if I untick this, already have this shape file. So let's remove this one. After this, we need to extract the information, the background information that have elevation system of Hawassa town from digital elevation model of Ethiopia. To make this, we can extract the system by go to the toolbar. This is arc toolbox. Okay, arc toolbox. So just to go to the arc toolbox, it takes a little bit time, and go to the spatial analysis tool. From the spatial analysis tool, we do have different type of information that has a capability to do the information of watershed management, interpolation, groundwater condition, generalization, and extraction, distance measurement, and so on. So we can extract our system by using extract by mask. Extract by mask is important for extracting information in terms of polygon format. So that was important. So go to the input raster Ethiopian digital elevation model, or the higher one. And the second one is the smaller one, that is Hawassa town, that you want to extract from the Ethiopian digital elevation model. And the output raster must be put in the folder, the same folder that you save your data. So copy the last extract ETO1, copy, and go to here. And I'm already previously extract the system, but let's again extract. Okay, and let's make it, this one is 2, then save and extract. It takes a little bit time. Yeah, we have already extract by mask. So thank you very much. So after that, if I need to delete this, the system clearly show me Hawassa is extracted from the mother digital elevation model, that is Ethiopia. But if you want to extract another data, for example, a little bit area of from Hawassa, the input raster must be uh, Hawassa, or extract one. So after that, let me remove Ethiopian digital elevation model. Sorry, let me remove Ethiopian digital elevation model, and let's make this one is zoom to layer. Zoom to layer, I already have this. After that, if you want to have some watershed system, we need to continue in the same way. So I will prepare another time this uh, video, but for now my interest is getting information about elevation of the area. So let me go to the global mapper and open my data that I was extract. Okay, so Ethio extract 2 is already available here, so call this one, so we can get this information. This information show me, if you see, the higher elevation is found on the bottom of the map, that is around 190.25 meter, 1925 meter, and the smaller elevation is found 1682 meters, that is found on the other part of Hawassa. But this information show me if I put the reservoir for water supply distribution system, always reservoir is put on higher elevation. So our higher elevation is found whether here or here, but from these two elevation system, this one is have more area, have more elevation. So we can take our elevation system here. We can take our elevation system here. So if I call the distribution system of Hawassa. Okay, this is Hawassa distribution system, and put here, put here. I have a lot of junction here, but this junction must be set in terms of reservoir, or set like reservoir. So after this, the next action is exporting this data into Excel. Okay, we can export this information into Excel, this export vector format, and go to Excel, that is CSV format. Okay, say it OK, and from this I need to export include attribute name and lateral and longitudinal information, lateral and longitudinal information. But don't forget, before you do this, we need to go to the configuration tool and said the projection must be set in terms of UTM. Okay, so after this we can export out vector format into CSV format by deactivating this symbol and layer, including attribute name and latitude and longitude coordinate. And if I have elevation on the system, just make it, you can include elevation and all boundary data I need to export. So this says save v file on water gems. Let's save it. Hawassa says CV. Okay, take save Hawassa says CV. Then save it. Okay, save it. Then after, if I go to here and check Hawassa, where it is found. Mm, let's check again the Excel file. Here is Hawassa Excel is found. Hawassa. So look, I have X and Y coordinates. Okay, source one, source two, and so on. Here I have all these things. Okay, but uh, this information is not considered Hawassa because I have two layers on the system, that is Kamise and Hawassa. That's why it export both, but I need only Hawassa information. Okay, I need only Hawassa information that have around 79 junction. After this, save this information and leave on. Save. In terms of Hawassa XL 97 2003 workbook and save. Okay, so after this, let's go to water gems. Let's go to water gems and open the file. Okay, then create new hydraulic model. Okay, make it yes. Okay, so we already get this in layered system. So the first action of WaterCAD is adjusting the tool by go to tools and more. Okay, I go to tools, make it option. So we can adjust the setup system. The first thing is unit setup, that is must be SI unit, and the drawing format is must be keep in terms of 1440 meter. This is a mapping system and the actual position. This information is depending on the map system. So for having a large map, the town, we need adjust high multiplier to see the symbol and the text. For having lower map or small map, we need to adjust the symbol and text height a little bit less. So once you adjust this, just make it okay. Just make it okay. So we can call the background information about the city. For example, if you need to call Hawassa background information, go to new and file, and we can go to the DXF file. Okay, I'm already have this map system only. Okay, only the map system. So it may call only the layer instead of having junction. It's only called the layer. But let me show you on another map by deleting this. by deleting this. Let me show you on another map. That map is called as Kamise. Let me call Kamise. Go to file and let's call Kamise. Okay, if I call Kamise, I may just make it zoom to extent, and I already have this Kamise map. So the next action is go to home. Okay, and we do have layout management system, as well as if it is not available for you, you can go to layout and put tank here. Okay, sorry, then delete. The first must be put in terms of reservoir. This one is also reservoir. Okay, this one is collection chamber. Okay, and the next one is tank. This one is tank. Okay, then make it connect by using pipe these two information. Okay, and this information, right click, make it done. Go to here, click and connect with the reservoir. After that, depending on the master plan, you can draw uh, pipe and junction. Okay, pipe and junction. Then once you finish this, if you deactive or untick this information, you can get clear information about the system. So let me show this on the finished map. By just let's go to file and open water gems. Water gems, let me see. Okay, it's a done file. So once you call this, the next action is filling data. So this filling data is done on the next video. Thank you for the watching. Thank you very much.